So we're going to kind of move and shift our attention over to taking a look at verifying inequalities. So verifying a solution for an inequality is a little different than just straight up solving for it. Really what verification means is the solution, will it satisfy? Will those values of your unknown satisfy the inequality? And that's really what that big difference between, verification and solution is. So if we're going to verify a inequality, and we'll kind of we'll kind of copy down the question here for ourselves. And they're saying that the solution is x is less than or equal to 32. What you want to do here is you want to choose a value such that x is less than or equal to 32. I don't actually want you to solve this right off the bat, but I do want you to choose a value of x is less than or equal to 32. So kind of play the game a little bit here. What kind of a value would you be comfortable working with that is less than or equal to 32? Now, many of you might choose 32 straight off the bat, and that actually can be a value that you use here since we have a less than or equal to. But there are a lot of other different values. So some possible verification values. X equals 32. That would be a possible one. Anything lower than 32, like 31, would be fine. 1 would be great. 0 would be fine. -1, -32, all of these values would be fine for a verification since they're all less than or equal to 32. Now, if we end up taking grade 11 pre-cal, what becomes pretty powerful in terms of a verification process, since the algebra is a little harder, this 0 becomes pretty awesome to use because, 0 minus anything is just whatever we're taking away. Something plus 0 is always what we started with. Anything times 0 is 0, and, well, we can't divide by 0, so that would be the one thing that we might have to work for. But this value here would satisfy. It would satisfy our potential solution of x is less than or equal to 32, just kind of like the question says. So let's verify with that. I like 0, it's easy to use, and we're going to use that for it. So I'm just going to kind of make a note of it, x equals 0 for verification. And again, verification is such an easy way to ensure that, you've done the question right. It's a way to say that, hey, I've gotten 100% of this question because my verification process has proven that my answer is correct. So the x is equal to 0 for verification, notice how we've just subbed in x is equal to 0 for any time we see x. So we saw x right here in our equation, and we've just subbed in 0 for it. So 0 minus 12 is going to be -12, less than equal to 20. Is this true? Yeah, it is. This is true, right? -12 is indeed less than or equal to 20. So we know that our answer of x is less than equal to 32 is, for our verification process here, it is in fact true. Now, there are a couple other ways that you can go ahead and do this. You might be asking yourself, well, hold on. What happens if, I just did the math wrong and I got this x is less than equal to 32, but then I plug in some other number and it's not right? And you are correct, right? We're only testing out one sort of boundaries, right? We're only testing this x is equal to 0, and then we're making a pretty general, broad generalization saying, okay, well then our answer must be right. And I realize that is, a little bit of a flaw in the approach, but for our grade 9 method of doing this, that's okay. It becomes a little bit more robust when it comes into, grade 11, grade 12, our verification processes. But for us right now, if we have an answer or are given a potential solution, like x is less than or equal to 32, then we can take that for granted and we can use that. Let's go ahead and let's do our b value here. So for B, I'm going to just copy down the inequality really quickly. 30, and we have our potential solution here is x is less than -6. So let's go ahead and let's figure out what we can do with this. So first off, let's kind of give off a couple of values that are less than -6. So we wouldn't be able to use -6 itself since we don't have an equal sign here, a less than or equal to. But certainly x is equal to -7, that would satisfy it. X equals -8. X equals -10. We can kind of keep on going through this for all values that are less than -6. It is pretty important to make sure that you know that something like a value of -1, 0, or 1, these are all very easy to work with, but these are not less than 6, so we can't use them for verification processes. So I would actually like to use this value. Now you might say, well, I just want to use a different one, and that's completely fine with me, but I really like working with -10. It's easy to multiply with, it's easy to divide with, it's easy to add and subtract. So I'm just going to use this value since it satisfies what they are potentially saying the answer is, and we should be able to figure out if this is right from it. So I'm just going to say x equals -10 for verification. And anytime I see an x in my original equation, I'm going to replace it with -10, just like we always would have done for verifications. Well, let's multiply these two numbers out, and let's just carry out to see what we get. -5 times -10 is 50, is less than 30. Is this a true or false statement? Is 50 less than 30? No, this is false. So this is not going to work. My x is less than -10 is not going to work. So clearly we have a very big issue. We don't have to test out -7 or -6. We only tested out one value and we found it was wrong. So we should come to the realization that this is the incorrect solution. Well, let's go ahead and let's solve it now. So we've tried to satisfy it with -10. It's not satisfied our inequality with it. So we have to go back to the drawing board. And as you probably remember from one of the first videos, is that when we want to isolate for x and we want to divide, in this case by -5 on both sides, we have to flip the inequality. So x has to be actually greater than -6. And again, the whole point of this was that since we divided by a negative, we had to flip our inequality sign. We have to flip our inequality sign because we are dividing by this negative value, or multiplying by a negative value. Now in this case, if we have our answer here, we can certainly go ahead and we can verify it if we'd like to, but we should be pretty comfortable with our verification process, and I think I'll leave it to you, if you're going to verify this new solution, that it would work. Let me just kind of go a little bit deeper here and just kind of say that if this one failed, and we know that this is the wrong inequality, and all they had to do was flip it to be x is greater than -6, well then it should make sense that any values that are greater than 6 would then indeed solve it, because they have the opposite of what we verified from before. So something like x is equal to -5, x equals -4. You can even use x is equal to 0 in this case, and it will ensure that this inequality is satisfied and our solution of x is greater than -6 is indeed the correct solution.